Welcome to section 4 trigonometric functions of any angle, part 2. And in this video, we're going to look at why do we have reference angles? How do we use them? And so where they come into play is, say we want to find the cosine of 4 pi over 3. Okay? Now, we know cosine of 5 key angles: 0, pi over 6, pi over 4, pi over 3, pi over 2. Okay? Now, this does not fall within that category. However, it is very similar to one of those. And so if we find the reference angle, so if we graph 4 pi over 3, if we look at, well, 4 pi over 3, that's just over pi, that's right here. Okay? So that's 4 pi over 3. It's in the third quadrant, so it's in number 3. And we want to know, well, what is the reference angle? Well, the reference angle is going to be this angle right here, which, since it's in the third quadrant, we're going to take the angle minus pi. So 4 pi over 3 minus pi, the reference angle is then pi over 3. So that's a reference angle, pi over 3. So what this does, cosine of 4 pi over 3, is the exact same as cosine of pi over 3, except for the sign. Okay? And so we have to look at, well, what is cosine of pi over 3? Cosine of pi over 3 is 1/2. So let's write over here, cosine pi over 3 is equal to 1/2. Well, cosine of 4 pi over 3 is going to equal that, except for the fact that since it's in the third quadrant, well, what do we know? In the quadrants, all the trig functions are positive in the first. Okay, so that's why cosine of pi over 3 is positive 1/2. But only sine is positive in the second, only tangent is positive in the third, and only cosine is positive in the fourth. Since we're in the third, that means cosine has to be negative, so therefore cosine of 4 pi over 3 is equal to a negative 1/2. All right, so what does that mean? In summary here, well, cosine, or any trig function, any sine, cosine, tangent of some angle is going to equal the same trig function of its reference angle, and then given the appropriate sign based on which quadrant it is in. Okay, so let's look at another example here. Let's say we have cosecant. All right, let's change it up here. Let's say cosecant of 11 pi over 4. So let's look at this angle here first. And this angle is 11 pi over 4. And so let's find the reference angle. Now, the first thing we should notice is, now wait a minute, this is bigger than 2 pi. So let's actually subtract 2 pi from that. And when we subtract 2 pi, we get 3 pi over 4. And so the reference angle there, well, 3 pi over 4 is in the second quadrant here. All right, 3 pi over 4 is going to be in the second quadrant, so its reference angle, we want to take pi minus 3 pi over 4, which will give us pi over 4. Okay, that's our reference angle. So we're going to use that to say, well, what is cosecant of pi over 4? Well, first off, what is cosecant? Cosecant is the inverse of sine, so we can ask ourselves, what is sine of pi over 4? Well, sine of pi over 4 we know is radical 2 over 2. All right, now what quadrant is this in? This is in the second quadrant we've established, because if it's 11 pi over 4, it makes a full circle and then goes another 3 pi over 4, so it's in the second quadrant. So that means that sine is going to be positive. So sine of 11 pi over 4 is a positive radical 2 over 2. But we want cosecant of 11 pi over 4, and we know cosecant is the inverse of sine. So cosecant of 11 pi over 4 is going to be 2 over radical 2, which is just equal to radical 2. Okay, so this this is the reason that we have reference angles, and this is the reason in class you found those reference angles, because now we can evaluate trig functions of any angle based on finding the reference angle and then assigning the appropriate sign given its quadrant. So in this next example, I'm going to show you how to do it in two different ways, and both ways are going to get us to the right answer, but it's using two things that we know, both graphically and our identities. So let's talk about the problem first. So let's say that theta, some angle theta, is in the second quadrant, and let's say that sine of theta is equal to 1/3. And we want to find what is cosine of theta and what is tangent of theta. So first, let's solve this graphically. Let's go ahead and graph it. So if this is sine of theta is 1/3, then that means that this is y over r. So our y value is 1 and our value is 3. So this is 1 and this length here of r is equal to 3. Now, if we wanted to find what is this x value, well, we could find that by knowing that r squared equals x squared plus y squared. And so we already have r, we already have y, so we could plug that in to say that, well, x squared is going to equal r squared, which is 3 squared minus 1 squared, and so that's 8. So that means that x is equal to 2 radical 2. That's taking the square root of 8, simplifying it to 2 radical 2. So this gives us x, y, and r, and then we could find cosine of theta by knowing that that is x over r. So that's 2 radical 2 over 3. And tangent of theta is equal to y over x. And so that's going to be 1 over 2 radical 2, which when we simplify this, that gives us radical 2 over 4. But then we have to stop and wait for a second and ask ourselves, now, what quadrant are we in? We're in the second quadrant. So is cosine positive or negative there? And so we have to think to ourselves, the all in the first, sine in the second, tangent in the third, and cosine in the fourth. Well, since we're in the second, only sine is positive, so that means that really this is a negative 2 radical 2 over 3, and this is a negative radical 2 over 4. Okay, now that's using it graphically, and that's drawing it, finding x, r, y, and using our ratios to find the value of our trig function for that angle. Now let's look at it a different way. Let's say we know that sine theta is equal to 1/3, and we know we're in the second quadrant. Okay, well, let's think back to our identities, that sine squared of theta plus cosine squared of theta, or cosine theta squared, you know, we're squaring the entire function, okay, is equal to 1. And so if sine theta is equal to 1/3, then 1/3 squared plus cosine squared of theta is going to equal 1. And so that means that cosine squared of theta has to equal 1 minus 1/9, which 1 minus 1/9 is 8/9, and then cosine of theta is going to equal plus or minus the square root of 8/9, which is equal to plus or minus 2 radical 2 over 3. Now, the question is, do we want positive or negative? Well, by the same reasoning we used in the previous method, we look at our quadrant. What quadrant are we in? We're in the second quadrant here, and only sine is positive there. So that means we want the negative root, which would give us a negative 2 radical 2 over 3. And so that gives us cosine, and to find tangent, well, tangent of theta is just equal to sine of theta divided by cosine of theta. Okay, and so since sine of theta is 1/3, cosine of theta is a negative 2 radical 2 over 3. We simplify this and we get a negative radical 2 over 4. Simplify and rationalize, of course. And so both of these give us the correct answer. Two different methods that we can use to find trig functions of any given angle or the given constraints. Okay, so you're going to continue to do problems like this in class tomorrow, and you're going to work on page 319, and you're going to do numbers 45 to 49, 59 to 63, and 81 to 84. Now, you do not have to do these for homework tonight. You're going to work on these in class tomorrow. If you want to take a look at a couple of them, go ahead. But this is just for your reference to help you in tomorrow's class.